Okay, for question 7b, look at this, convert into decimal notation. So that means we need to do this at 200, right? Because we have 2 times 10 squared, which is 200. And this is called a decimal notation. Even doesn't have decimal, right? We can put decimals after 200. We can put a dot, 0. So 200 just 200 dot 0, 0, 0. How many zeros you put in, after that? It doesn't make any difference. But this is called decimal notation. So scientific notation, we did it before. So 2 times 10 raised 10 squared, that's scientific notation. All right, so now let's see number 8. We want to see if this relation is a function. We really didn't talk about, didn't cover in class, but however, this is on review sheet, so let's go over this. And if it's a function and all relation we want to find is a domain and range, right? So a function is a special relation in between two variables. So if I make, imagine this is a set of something, and this is another set of something. So a special relation in between those two makes a function as such. Think about students in our classrooms, right? And maybe let's say Amy, maybe Tom, right? Just as an example. So Amy, so the second set can be age or can be something else, right? I just making an example. So Amy is 18 years old and Tom can be also 18 years old. And maybe we'll have someone in the class 20 years old, so on and so forth, right? But if Amy is 18, Amy cannot be 20, right? Because everybody only has one age. So if Amy is 18, Amy cannot be 20. So which means if A maps to 18, and A cannot be mapped to any other number in the range. So this set we call range. So this second set is called range. And the first set is called a domain, right? So you can imagine, so the first set is the names in one class. And the second set is ages for students in the class. And this kind of relation will make a function. Because A assigned to be 18 years old, Tom assigned to be 18 years old, and so on and so forth. Amy, if Amy is 18, Amy won't be any other ages. So this relation is a function. Pretend we have another some kinds of relation between two sets. And if in the set A is mapped to 18, and also A can be mapped to any other number, there won't be a function, right? So in brief, if any member in the first set assigned only one value in the second set, that makes a function. So to this we call ordered pairs, the points. Let's see, check if this relation, so this is a set of 4 points. So the first member, let's look for the same first member. So we have -1, -2, -3, then -1 again, right? So -1 be mapped to 2 here for this point. But then -1 be mapped to 1 also. So that's not a function. So this relation won't make a function because the first member -1 being assigned to 2 values. It's like to see Amy here has 2 ages. Amy is 18, Amy is also 20. Right? So that's not a function. So this is not a function. What is its domain? Domain are the first members in the set. So we use this set notation to see, okay, -1, -2, -3, 3 members. Range is the second member. range is second member, we also use set notation. Is 1, 2, that's it, only 1 and 2, right? You see here, we have 1, we have 2, we have 1, we have 2. Okay, now let's see 9. 9, we want to evaluate function at a given value for x. So here we have a function, and this is a polynomial function, polynomial degree 3, because the leading term has exponent of 3. So polynomial degree 3 function. And we want to evaluate at x equals -2. So what do? We just change x value to be -2. Wherever we see x, change it to be -2. I'm sorry, bear with me because it's difficult for me to handle this tablet yet. So that's so we start with the negative, but the x itself is -2. So -2 raised by 3 minus 3 times -2 square minus 1, right? We just follow the function. So this is how the function defined, right? Whatever the input is, so x represents any input. So now it's a -2. So I have -2. So this was x before, right? And this was x before. Now let's do the calculation. Well, -2, let's say this negative sign. -2 cube is -8. Okay, just pay attention here. This, very easily to make mistake. I have negative sign up front of -2 cube. So I keep this negative sign, and then -2 cube is -8. A negative will give me positive 8, right? Then -3 times -2 squared become positive, right? +4 minus 1. Well, 3 times 4 is 12. So we have a minus 12 minus 1. Well, a minus 12 is -4. -4 minus 1, that's -5. And that's it. Okay, that's it. So evaluate this f of x at x equals to -2, which means find the value of f of -2. And we did. F of -2, we just plug -2 into every place of x. So x being cubed, -2 cubed, 3 times x squared, -2 squared. All right, so we do the calculation. In the end, f of -2 equals to -5. So when we graph, that's a point, right? X value is -2, and the function value used to be y value is -5. Okay, so number 10 is identifying function values, domain and range from a graph. Let's see this one. So, right, function has a couple of representations. Function can be represented as algebraic expressions, like the one we see, can be represented by a graph. So this is represented by a graph, right? So domain is talking about the x value, right? The x starts, so we always look from the left to right. So start from left, then we look to the right horizontally. So the function, the graph ends here. So starting at -3, end at 2. So that's the domain. So we use the interval notation. So domain, oops. Why can I go up there? It does not. Okay. All right, I made it. So domain, we use the interval notation. Because we see solid dot above -3, so we use bracket for -3. And then we see open circle above x equals to 2. So 2, we do close parenthesis. So that's our domain. Range, we look at the y value. We look at the y value from bottom up. So from bottom up. So start from, we see -3 here. Then bottom up, then we see ends at 6. And 3 is a solid dot, right? Even we didn't intentionally make a solid, but it is, 1 point on the graph. So it's a solid. So the range we started with also, that's a coincidence. All right, it's just a coincidence, same as the x, the domain -3. Then end at 6. 6 with an open circle, so end with close parenthesis. So this is the range of this function. Again, domain talks about the x value. I will look from left to right. We use the interval notation. And range will look from bottom up. Bottom up. We write in interval notation. Okay, also the question asking, what is f of -2? F of -2 means x value equals -2. So we go to x-axis. We're looking for, let me change my color. Change the color. Why can I go to what? Okay, got it. So I find my x value equals -2. Okay, right here. Okay, x equals -2. Then I go to the graph. I see the graph is down here. All right, so that's the function value. So I find this point on the graph on the vertical line of x equals -2, right? So I see the function value also equals -2. You see this point, right? This point, x value is -2 and the function value is -2 also. So I know f of -2 also equals to -2. And f of 2. F of 2 means I look at x value equals to 2. So x equals 2 is right here. Then I go to the graph. Well, where's the graph? Oh, right here. Right? It's a 6. However, that's an empty circle. It's an empty circle. Even looks like a 6, but because it's an empty circle, so the function value does not exist. So we see does not exist. D and E does not exist because it's an open circle. Let's look at 11. Combining different functions using addition, subtraction, multiplication, or division, right? So I have this notation. This means f of x minus g of x. So f of x minus g of x. So this is just a notation wise. Okay, f minus g of x means exactly f of x minus g of x. Okay, so let's see. So 4x squared minus -3x squared. So this one equals to 4x squared minus -3x squared becomes 4x squared plus 3x squared. So we get 7x squared. Then we have -2 minus -2. Well, -2 minus -2 becomes -2 plus 2. That becomes 0. But then we have a minus -5. Minus -5 becomes plus 5. So f of x minus g of x is 7x squared plus 5x. Now let's see 12. So rewriting the equation of a line in slope-intercept format. Remember, slope-intercept format is y equals to mx plus b, right? M is a number, b is a number, x, y represent any point on the line. So we're given this, we're given ax, excuse me. We're given ax plus by form equals c form. So we want to be able to write as an interceptor form, basically solving for y. Isolate y on one side of the equal sign. So first, we want to move 2x to the other side, right? So positive 2x, when we move to the other side, it becomes negative. So 12 minus 2x. Or you can think minus 2x on the two sides of the equation, right? Same thing, same principle. So what do we get? We get a negative 3y equals 12 minus 2x, or negative 3y equals to negative 2x plus 12, because 12 is positive. 12 is positive, so it's plus 12. Then we divide by negative 3 on both sides. Divide by negative 3 on both sides. So we get a y, allow me to write up here. So y equals to negative 2x divided by negative 3. Negative 2 divided by negative 3, that become positive 2 divided by 3. Well, x in the numerator, we can write on the side. So 2x over 3 or 2 over 3x. We want to write this form because this is mx plus b, right? Then 12 divided by negative 3, that's minus. 12 divided by 3 is 4. So the y-intercept form is y equals to 2 over 3x minus 4. So the slope is 2 over 3, and the b is negative 4. Let's see 13. 13, we want to use point slope form of a line to find its equation from 2 points, right? So I'm given here 2 points. Let's call this one first point. So name the x value x1, name the y value y1. Let's call this the second point. So the x value we call x2, the y value we call y2. So we want to write slope-intercept form. Remember what is the form? That's y minus y1 or y2, doesn't matter which point we choose, equals to slope times x minus x1. So in this case, I choose to work with x1 and y1. You may choose x2, y2 if the value is easier, but the answer comes out the same. So first we need to find slope, m. If we remember the formula for finding slope from 2 points, that's y2 minus y1, difference in y value, right? Then divided by the difference in x value, which is x2 minus x1. You may do y1 minus y2, but then the denominator has to be x1 minus x2. All right, you have to, so the point has to be consistent. Now let's plug in the values. So y2 is 4, y1 is 2, so 4 minus 2, which is 2. And x2 is 1 minus negative 3. Negative 3 is x1, so 1 minus negative 3 becomes 1 plus 3, which is 4. 2 over 4 can be simplified to a half, right? So we divide by 2 in the numerator, divide by 2 in the denominator, so we get a half. So that's our slope. Now with the slope, we can write our y-intercept form. So you may choose to work with the x2, y2. Let's choose to work with x2, y2, so we don't have to deal with the negative numbers. So y minus y2, which is 4, y minus 4, equals to slope is a half, times x minus x2, which is 1. Right? If you want to simplify, you can simplify it. Otherwise, it's just leave like this. Or sometimes maybe we want you to write in slope-intercept form, right? In that case, let's just do one step further. So we move negative 4 to the other side. Also, we distribute this half into x, this half into negative 1. So we get a y equals to half x minus half plus 4, right? Minus half comes from -1 times half, plus 4 comes from the -4 from the left-hand side, move to the right-hand side. So we simplify a little bit, we get a half x plus, well, 4 minus half, that's a 3 halves, right? Or 7/2. Okay, so the answer for 13, the point, the slope intercept form for the 2 points given is y equals to half x plus 7/2. Now let's look at 14. So here we want to find a line given the point, then parallel to some other lines, parallel or perpendicular. So you remember, if two lines are parallel, their slope are the same, right? If the slope of the first line is called M1, the slope of the second line called M2, they equal to each other. So two parallel lines have the same slope. Well, perpendicular is different. Perpendicular means the two slopes are opposite inverse, which means if we multiply them, we get -1. Or we can rewrite this into two more equations. Let me write in this empty space. Or we can write M1 equals to opposite inverse, right? This is still M1 times M2 equals to -1. But writing this way is helping us to find the slope. If we know one slope, we just do opposite inverse to find the slope of the perpendicular one. Okay, let's see this example. I think I need to erase. It's too messy. How do I go up there? Okay. Yeah, I need to learn how to move around this stuff. All right. So now I need to go back to get my pencil. It's a little bit tricky. Okay. So the first one, 14a, we're given this point, and we are told the line we're trying to find passing this point parallel to this one. So parallel have same slope of two lines. That means we need to draw slope from here, from this given line. So how do we get that? Well, let's move this -y to the other side. Remember, when we're moving from one side to the other side, it just changes the sign. So -y, when we move to the other side, become positive. So no more -y on this side. So same thing, we're going to move 5 to the other side. 5 on the right-hand side, positive. When we move to the left-hand side, becomes negative. So that becomes equation, we can write on the left-hand side. We can switch the left-hand side and the right-hand side. So we can write as y equal to 2x minus 5. Oops. So what's the slope? Slope is 2, right? Parallel says they have the same slope. So we have a slope equals to 2. And then we have 1 point. We can use slope point set formula. Slope point set formula saying y minus -1 equals to 2 times x. Why am I writing m? X minus 1, right? Minus -1 becomes y plus 1. Then this subject have 2x minus 2. Right? If the question doesn't ask you to do slope y-intercept form, you can leave as slope intercept form, right? Now let's see the second one. Second one is perpendicular to this one, to -x plus 3y equals 9. Let's move 9 here. So let's move 9 there. Okay, so negative x plus 3y equals to 9. Let me erase something so I can have more space. Let me erase this. So let's write 9 here, right? So same thing, I need to find the slope from this given line, given equation. So what do? I move negative x to the other side. It becomes positive x, right? So no more negative x on this side. Now 3y, I want 1y only. I need to divide by 3 on both sides. So I get y equals to, let's look at the x term first. Do you see 1/3 of x, right? X divided by 3 is just 1/3 of x. Because 3 in the denominator is not 3, it's 1/3. X in the numerator is the same as x on the side. Then 9 divided by 3, that's positive 3, so plus 3. So all I need is this slope, right? Slope. Now I'm using this relation because it's a perpendicular. Perpendicular has such relation, right? So I'm trying to find the slope. The equation goes through this point and perpendicular to this line, which has slope of 1/3. So what I'm going to do, I'm going to do negative 1 over 1/3. When we have 3 layers, so this is in 1 divided by 1/3, so negative. So it's still negative. Then 1 divided by 1/3. How do we divide by a fraction? We change division into multiplication. We take the inverse of 1/3. What's the multiplicative inverse of 1/3? Which is 3 over 1, right? 3 over 1, usually we just don't bother to write divided by 1. 3 apples shared by 1 person, it gets them all, gets 3 apples. So we just write 3. We don't really write 3 divided by 1. Negative 1 times 3, that's negative 3. Right? Do you see opposite inverse? So it's 1/3 positive, opposite is negative. Inverse of 1/3 is a 3, right? So opposite inverse. Now with this slope negative 3, we can use y-intercept formula. I mean, point set formula is y minus 2 equals to negative 3 times x minus negative 4. Minus negative 4 becomes x plus 4, right? We can leave it like this. If the question asks you to write a intercept slope form, you do y equals to, you see negative 3 times x, negative 3x. Negative 3 times 4, negative 12. Then we have this 2, negative 2 move to this side, plus 2. We simplify, get negative 3x minus 10, right? Negative 12 plus 2, that's a negative 10. And that's it. That's the perpendicular one to the given equation past the point of negative 4 and 2. Okay, that's 14. Now let's see 15. 15. Let me get my eraser. I really like recording, class or recording. Before COVID, I don't really know how to handle online class. After COVID, I think I really like online class because I can record every class and then, post it. So you can watch, very convenient, become very convenient for for student. You can watch in your free time, or you can watch anytime you want, or something you do not understand, you can, you know, go back to watch them. But in class, but too bad, you know, right now colleges are going back to on campus. On campus, maybe next semester I'll try to record my classes, so then post it. Because if, you know, I talk everything in class for 2 hours, then I have to, every time I need to, you know, to erase the board, how much you can write down. Can you really write down everything I was talking? But if I record it, you know, you can always go back to watch. And it also will help me to be a better teacher too. So, you know, next semester I may try that too. Okay, now let's look at 15. So solve a system of linear equations. So what we call linear? Linear means the exponents of the variables, just one. Using graphing substitution or addition method, basically saying using any method you want, all right? Let's see which, you know, which one we want to do. So here we have one equation. Linear equation always represent a straight line. Okay, so this represents a straight line. This represents a straight line. If the system has a solution, that means those two lines intersect. Okay, these two lines intersect at one point. Or if two lines are the same line, right? If this is line, the first line, and then the second line is exactly the same as the first one, so they will meet at every point. In that case, we see the infinite many solutions. Or one solution, either one solution or infinitely many solutions. Or we have one more situation is the two lines are parallel. They have the same slope. So which means they will never meet, which means there's no solution for the system. So we have these three kinds of solutions for solving a system. Well, let's see this one. So the first equation will have 4x plus 3y equals 14. The second will have 2x plus 3y equals 4. Like you can use graphing, but for me, it's difficult to use graphing. If you have grades to work with, right, you can graph. Because if I draw, I won't make, you know, exact grades. It's difficult to use a graphing to solve this. So what I'm going to do is probably I'm going to use addition or subtraction method. Because why? You see I have 3y in the first equation. I have 3y in the second equation. When I talk about 3y, it means positive by default, right? Positive. So what do? I can do subtraction. So I subtract vertically. Why I subtract? Because 3y minus 3y or 3y subtract 3y gives me 0. That's how I get rid of the y variable. So then I have 4x minus 2x. 4x minus 2x, that's just 2x. 3y minus 3y, that's 0. I don't bother to write 0 in my equation. The equal sign, I still inherit equal sign. Carry on with me. Then 14 minus 4. Well, what's 14 minus 4? It's 10. So all of a sudden, I get 2x equals 10. So what I do, I need to find x. So I divide by 2 on both sides. So I get x equals to 5. If I get x equals to 5, I need to solve for y. So I can use either equation to solve for y. Let me use the first one. So 4 times 5 plus 3y equals to 14. Right now, 4 times 5, 20. I'm solving for y, so I want to move this 20 to the other side. 20 positive on the left-hand side. When I move to the right-hand side, it becomes negative. So 14 minus 20, how do I do this subtraction? 14 is less than less than 20. So basically, I do 20 minus 4, then carry on negative sign. So I get negative 6. Now I divide by 3 on both sides. So y equals to -2. So we have one solution, which means 1 point. X value is 5. Y value is -2. So this is the solution for this system. So that's the first situation. That means the two lines meet at 1 point. At such point for this one is 5, -2. Okay, now let's see 16. 16, using a system of equations to solve a problem. So life applications. A flour mill mixes a 40% whole wheat flour. Oh, actually, in my first class today, someone asked this question. Okay, I think there's a typo here. You see the 40% is whole wheat flour, then 70% also whole wheat flour. So what do we do? Let's just change one, not a whole wheat. Just wheat flour, okay, it has to be different. Otherwise, it just doesn't make sense. So let's change the first one to be 40% of wheat flour. And the second one, 70% of a whole wheat flour. So I have two different kinds. To obtain 60% whole wheat mixture. So we need to interpret this English into mathematical equations. So the question is, if 45 kilogram of final product was obtained, how much of each type of flour was used? Let's name some variables. Let's see, the wheat flour, we need W kilograms. Okay, the whole wheat flour, you know what? Yeah, maybe we use the first one just as flour. So it's not whole wheat, just flour. So let's call F. So we need F kilogram from the wheat flour. And we need a whole wheat W kilogram from whole wheat flour. Okay, first we name variables. So once we have these variables, we form equations. So 40% of wheat flour multiply, right? Plus 70% of whole wheat flour, right? To obtain 60% is percent of the final product is how much? 45 kilogram. Okay, means F plus W is 45. In the end is 45. Okay, something 45. The mixture is 45 kilogram. All right, so now, so we have three terms here, right? We have 40% F, 70% W, 60% of 45. We see all those three terms divided by 100. So we just can multiply by 100 to cancel out this. So then we have 40F plus 70W equals 60 times 45. We can also divide by 10 for all those three terms. Now we have 4F plus 7W equals to 6 times 45. Oops. Okay, so we have 4F plus 7W equals to 6 times 45. Now we have trouble here. We have two variables, one equation. Won't be able to solve for one solution, like infinite many solutions. But we want to come with one solution. So what else? We need to make another equation. We need to make another equation. So we see 45 here is the total kilogram total weight of the product. So which means F, the wheat flour plus the whole wheat flour has to be same as the mixture, so 45. So that means we can write F in terms of W, 45 minus W. So then we use that, so we have two equations, right? We have one F plus W equals 45. Another equation is 4F plus 7W equals 6 times 45. So now we have this, we have F equals to, so those two equations, you may use elimination or substitution. I'm going to use substitution method for this. You may use elimination method too. Okay, I'm going to use a substitution. So I'm going to do 4 times F, which is 45, minus W plus 7W equals 6 times 45. You may multiply 6 with 45, but I like to leave it in the middle of a calculation. I don't want to spend too much time to punch into the calculator or to calculate this. I will carry with me. Hopefully, on the way, I can simplify with someone else. So now I have 4 times, so I distribute this 4. I have 4 times 45 minus 4 times W, then plus 7W, then equals to 6 times 45. So negative 4W plus 7W is 7W minus 4W, which we get a 3W. Now I want to move this 4 times 45 to the other side. When I move to the other side, it becomes negative. Now you see I have 45 as a common factor. So I factor out 45. I have 6 left for the first term, I have 4 left for the second term. See, now the calculation is much easier, right? 6 minus 4, that's 2. 2 times 45, that's 90. So 3W equals to 90. Divided by 3, so W equals to 90 divided by 3, 30 kilograms. So that means F is, okay, F is 45 minus 30, which is 15. So W is 30. So we need a 15 wheat flour and a 15 kilogram of wheat flour and 30 kilogram of whole wheat flour to make the mixture of 45 kilogram. All right. Oh, computer. This is my new adventure using this drawing tablet. It's a lot better than me writing with my fingers. It's just so hurtful, yeah. Anyway, let's see, 17. 17, after I finish 17, I'm going to take a little break, okay? So 17 is inequality. So let me erase some of this so I get more space. Oops. All right. Change the pen. Come on. Let me use red color. Okay. So solving inequality. Let's see. We see annoying half there already. So if we want to, we can get rid of this half. But for now, that's okay, because we only have one fraction, only half, right? So what do? Let's distribute first. Let's do, because we want to combine like terms on two sides, right? So we want to combine the x term with the x term, the y term with the constant term with constant term. So we distribute this 7. So which means we multiply 7 with the 2x. We multiply 7 with the 6. Then same thing on the other side, we need to multiply -6 with 3. We need to multiply -6 with negative x. So 7 times 2x, that's 14x. 7 times 6, that's 42. Less than sign, half x. Then -3, -6 times 3, that's -18. -6 times negative x, negative times negative become positive. So we get a positive 6x. Now we want to combine the like terms. So we see on the right-hand side, we have the half x, 6x. So that gives us 6 half x. So we don't want to keep at 6.5. So we want to do improper fraction. So 2 times 6, that's 12. So basically we change 6 as 12 divided by 2. So 12 divided by 2x divided by half x, that's 13 over 2x, right? So this is greater than or equal to, so this -18, we have -18 here, depends. If we want to keep -18 here, that's -18. So basically we have combined half x with 6x. So which we write as 13 over 2x. Then we still have -18 here. So the other side, we have 14x plus 42, right? So now let's move 13 over 2x to this side. Same thing, same time we'll move 42 to other side. So we get a 14 minus 13 over 2x. So this is the x term, less than -18 minus 42, right? So we moved x term with x term, the constant term with constant term. So 14 minus 13 over 2. So what do? We want to multiply by transformer 1, and this one is 2 over 2. So we get 28 over 2. So 14 can be written as 28 divided by 2. Then minus 13 divided by 2. So that's our x term. Less than, well, what's -18 minus 42? Both numbers are negative. So we add them together, we keep the negative sign. So 18 plus 42 is 60. And keep the negative sign, so -60. So here on this side, 28, we have common denominator of 2. So we just perform the operation subtraction with the numerator. So 28 minus 13, we get a 15, right? Yes. So we get a 15 over 2x less than 60. Now, we want to get rid of this 15 over 2. So basically, we need a 1x. So how do we change 15 over 2 to be 1? We multiply by its inverse. Its multiplicative inverse is 2 over 15. But we got to do on both sides, right? 2 over 15. Multiply 2 over 15 on both sides. You see, then when we multiply those two, the numerator becomes 30. 2 times 15 is 30. The denominator is 15 times 2 is also 30. 30 divided by 30 equals to 1, right? So multiplicative inverse, they always multiply to be 1. So we just get x less than 60 times 2 over 15. How do we multiply those two numbers? We could do 2 times 60 to get 120, then divide by 15. We could do that, but that's the easy way. The easy way we see 15 is the denominator, 60 is the numerator. We can also perform cancellation. So we see 15 is a factor of 60, right? It's a 4 times 15. So 60 is 4 times 15. Or to see 15 goes into 64 times. So then this says that it becomes 4 times 2 now. Right, so 60 divided by 15, that's 4. 4 times 2, that's 8. So our solution for 17a, I have run a long way, I'm sorry. So 17a, the answer is x less than 8. And we need also to graph the solution on the number line. So the real number line, we put an arrow here. We make the origin 0, and we mark number 8. Less than means going to the left. Without the equal sign, we want to make an open circle on top of this 8. Then we indicate all the numbers less than 8, right? So basically you can imagine negative infinity on the left-hand side. So that's the graph. So negative 8 down to negative infinity. Down to negative infinity, we indicate with an arrow. All right, I'm gonna take a break, okay? Writing on the board, I'm not getting used to this board yet. So I'm going to do that. I'm going to stop it sharing. I'm going to end this meeting.